It's taken a long time to encode. It's only about 82.5% done now, and it's been encoding for about 2 hours. So, if you're going to make a complicated video that's even only a half hour long, it may take hours for it to encode. And that's part of the reason why we don't mess with the videos that we do for the daily space weather. We basically record it like a live session, and we don't do any edits because it takes so long to encode, an HD video. I hear that. Yeah, good point. And another way to avoid. Oh, go on. Hmm. Another good way to avoid copyright problems, like with a still image, is to edit the shit out of it. So, if you have an image of Jupiter and you make it blurry and totally change the contrast and the hue and the saturation, it's not a copyrighted image anymore. If you substantially change some piece of anything so much that it's not really readily recognizable as what it initially was, nobody can really claim a copyright.
The industry standard is 25% because of what they did with Star Trek. Obviously, you need to change something at least 25% to make it your own.
Yeah, and if you look at our daily space weather thumbnails, they often have copyrighted images in there, but there's lettering over the top of it, and those images are designed to convey what the video is about. Almost 100% of the time in a non-clickbaity fashion. So, yeah, exactly. Yep. Yeah. Hubble, ESA stuff, any sort of government stuff, it's pretty much free game. Well, I'm sure he did. And what our conversation really came down to was two things. It was mainly just general relativity, and we were talking mainstream because this has to do with the formation of my nonprofit charter and stuff like that. So this is a fairly mainstream conversation. Nothing. I don't think it'll be too exciting for anybody in Electric View because we didn't get in the weeds very much at all. But the main 2 points are viewing the universe through the lens of general relativity or viewing the universe through the lens of quantum field theory. And pretty much,
or electromagnetic forces down in the quantum realm. Yeah.
Yeah, you're going to have to view the video if you want to hear what we talked about. Correct, and
Yeah.
this is part of the reason why I entitled it "Theory of Everything," because what yeah, and what we're really interested in here is the way things work, the physics behind how things work at a subatomic level and at going light speed and at a intergalactic scale.
Well, when I said that, I was just referring to the fact that when they express the boson or the quark or any of the other particles that they say that they may have found, they express it in terms of cymatic patterns. That's electrical, not particle. So that's why I said electromagnetic down in the quantum realm. No, as opposed to the standard science model. That's what, the standard science model of relativity that can't be put together. Einstein tried. I know this. I know that.
Well, they can't put it together because they separated it in the first place. That's what the whole thing is that you go through the relativity, you become, that's what they did, is they become atoms and particles. And that's why they can't unify, because they separated it. So the only thing that they can actually do, besides, since relativity separates the things, you can't put it together. The other thing is that you have to go to the quantum, not quantum mechanics, but which is particles and atoms, but you have to go to quantum fields or waves or whatever you want to call it. I call it Maxwell waves and quantum fields. Those are the 2 things that can unite it. But they united it by putting a relativistic electron inserted in the quantum fields to give it. They inserted the electrical into it. And so the real question is, how can they put these things together so that they don't cause problems? They're causing problems because they put a particle in the quantum fields thing. You can't do it that way. We have to insert cosmic charge into the quantum fields in a way that will work. That's where you're going to get something that'll work, I think. So that's my opinion.
That makes sense, James. That really does. Neil, is your mic muted for
Yes,
everybody?
yes.
They're saying that it is in the live chat.
Oh my goodness, it was.
We can't hear Neil. You might want to
Please
go over
rewind
that
what
again.
you just said, Neil.
Yeah, I know,
Yes,
eh?
please go back about a minute or two, what you just said, because that was crucial.
I couldn't believe that. It's the thing is, and I'm just going to be honest with you, the part of my mixer changes where it puts video capture device and mic aux. It interchanges it, one or the other. And so even though I think I'm hitting the right button in OBS, I'm not. I'm hitting a completely different button because
That's the worst.
yes, and so and it changes every time I load a new intro or a new scene or a new screen. So here I am thinking that I'm chatting. Here I am thinking that I'm doing everything, and nothing is going across.
All right, so I've sent an image here into the chat. I don't know if you want to screen share that or not. If you can, that would be great. It's an image out of one of Eugene's textbooks that he actually had to translate from Cyrillic Russian, and it's showing what the three different vectors and where the likelihood of these systems to be able to describe the universe for real. On the left, you've got relativity and reference to light speed. In the north, you've got the quantum field theory, and then on the right, you've got Newtonian physics, and then kind of in the center, you have general relativity.
No,
and there's sort of lines
that
where the
that right there would be the as we were talking, trying to get the quote unquote grand unified field theory, the whole understanding of everything. And like I said, if we're in a nutshell, if we were to put it into with removing relativity, this is because obviously in the electric understanding that's probably not the case. To remove that, then you're looking at classical and EM. And I'm basically repeating what I said before when I was completely muted and totally screwing up once again for everybody.
And Eugene agrees with you too. That's you're right on the money with that as far as what Eugene says. So there's I see no disagreement there.
Oh, and I'm positive that we see the same on that.
What's interesting is Eugene actually didn't know anything about the recent publications about accretion through polarization. So that was interesting. I brought that up to him yesterday, and he hadn't heard anything about it. I hadn't even sent him an article yet. I should probably find that article and reach out, because that's
interesting.
It's because we've never done an experiment in microgravity which shows that mass causes things to accrete, but we have done one just in the past year that shows that polarization causes glass beads to accrete. So
are you talking about that Russian one?
It took place on the International Space Station. I'm not exactly sure which group did it.
It was the Russians, and it was 2013. I'm positive I know what you're talking about.
Yeah, I saw that video too.
Pretty recent.
Well, that is fairly recent, but.
Well, see, that goes to my thinking. I kind of picked it up off of Rex. He says, well, why can't there be many different ways of planet accretion, star accretion, galaxy accretion? Why can't there be many different ways of doing it? We see a lot of different types of galaxies out there. None of them are exactly the same, but, we have categories for them. So maybe it's just different ways of making these things that then join the circuitry.
But they're all unique. And that's the thing. There's uniqueness on every single scale. Even though there might be 1 million or 1 billion people, they're all unique. Even though there's 1 billion bunnies, they're all unique. 1 billion atoms, 1 billion carbon atoms, they're all unique. 1 billion galaxies. So there's something about the uniqueness and the
and yet they all follow a certain set rules that are provided to us from nature itself, the universe itself.
The mechanics of the toroid and the vortex and the helices is ultimately, if you look at inside and out of all species and space-time geometry, that can in and of itself explain by wrapping inside of itself through helical knots and knot theory and whatnot, as well as some of Roger Penrose's theory on twistors. You can explain the morphologies of galaxies and galaxy mutation straight into the sonobiology and the sound of the auroras, literally pulling. Did you guys see the that BBC thing of the sound of the auroras?
I've
Negatory.
heard them before.
It is absolutely amazing. It's one of the most magical things in the world. I've been sharing it quite a bit. And on our recent episode in the geometric view, we covered it.
You can actually hear them go around the planet like like whistlers.
Yeah, indeed. So I took it a step further, and I suggested or hypothesized that these whistlers are responsible for pulling up the growth of living plants and trees like conifers, and the conifers mimic the sounds and of the auroras, and dogs, packs of dogs and wolves howl, and I think dogs speak in auroral language, as far as and there's ways to actually do experiments to see if the wolves are louder during auroral storms, and they speak with the sounds of them, because if we can hear them with our ears and equipment, dogs can. So my theory here that I'm proposing is sonotropism, the sound literally pulling up the forms into manifestation. And this also goes into diatoms and why diatoms are the structure and why they are the geometry of what they are. And diatoms eat the exact same thing. They're pretty much like plants. They have the exact same diet as trees and plants. And they are the nutrients for most of the other living creatures. So from there, the cascading sound and resonance envelops and creates a path that is already there, inherent, or a scaffolding for the rest of matter to materialize off of. So you can hear these sounds inside of the whales and the language of things that are underwater. You can hear the same sounds in the cracking of ice. You can hear it in the wolves. You can hear it, and there's just many things that we're familiar with that make these types of sound. So add that with some of what Eugene's talking about, and you have you have a unified nesting of how sound envelops itself and creates living beings acoustically off of these tendrils that are filaments. Each individual unique filament is part of the cascade off of the sun, and they're all part of the food cycle, and you can't have one without the other. They all necessitate each other out of the octave growth. You can see it
I listened to cosmic so-called particles hit the atmosphere, and they recorded that, and it sounds exactly like the kind of tweaks and bleeps that birds do.
Exactly.
So,
that's very interesting. I never thought of that.
Yeah, and Pi says that the auroras are ULF and VLF, and that the whistlers and chorus come from 60 degrees north parallel, And the Higgs
Yes,
comes from 60 degrees south parallel. That's what she said.
Wow, it seems to me that we just figured out a way to talk to the animals, to figure out that what part of the electrical spectrum of sound that they're listening to and mimicking and using as their language. Wow. It was said that I think it was in 2018 was the year that humanity was supposed to be able to talk with the animals, to figure out the way to talk to the animals. Somebody had foretold this. Or, no, not Dr. I can't remember where I heard that, but someone had said a long time ago that in 2018 humanity would figure out a way to talk to the animals, and Buddy might just have hit on something there.
Well, this isn't just a hunch. This has been experimentally verified, and I've done a lot of research to show sonotropism and sonobiology. This is really the cascading because.
Well, all I'm saying is you're a couple years late. That's all.
Well, there's a word for this, and the word for it was written a long time ago. And where's my book? It's right here. This word was written in pre-Socratic times by Anaximander, and it's called apeiron. And an apeiron is a unified substance that describes everything and precedes everything. And Anaximander was the first vortex scientist and one of the first metaphysicists ever to live, because he was able to take matter and because we were trying to describe everything.
Sounds like plasma. Is that plasma? Sounds like plasma.
Matter. But it does sound like plasma. It sounds exactly like plasma.
Don Scott calls it the zeroth material, like the zeroth phase of matter.
I call it the alpha and omega, because plasma is the primary state of matter. Then it gets condensed into solids, liquids, and gases, and then you apply enough energy to it, it gets put back into its plasma state.
Well, when it dies, upon cessation of motion, it gets dispersed back into the akasha, or the ether. Yeah. But he was a student of Thales, and I just wanted to say that. And these ideas are 500, 600 BC, pre-Socratic, pre-Pythagoras. There's another guy I want to. If I already said Anaximander or Anaxagoras, they're both amazing. But they came about these ideas by understanding vortexes and studying vortexes. And all throughout all of the big toe, the theory of everything, or the gut, grand unified theory, you have the vortex scientists, and all of the most influential of them were part of the vortex scientist movement. I'm reading this book right now, The Space-Time Origin of the Universe by Vladimir B. Ginsburg, and some of the stuff that I've been quoting is out of this. And another amazing person, I can't even pronounce his name, Empedocles of Akiko, Greek philosopher. This guy actually did an illustration of a teacup, and he said that the Earth hovered in an upward draft in the primordial vortex. This was 490 BC. So our understanding of this stuff goes back to just a basic understanding of vortex science. And the more we understand vorticity, and the more we will come closer to, I believe, closer to understanding what the gut and the grand unified and the theory of everything is.
Well, vortices and the Fibonacci, and now the Doherty set, and all of that stuff, all of the what's referred to as natural mathematics or geometry or sacred geometry, those are the things that we really have to pay attention to, because that's nature.
Yes.
Edition of
Well,
the
it's
Electric View.
true.
I'm Neil Thompson.
You can't falsify.
Today we're
The
exploring
only way you can
unified
prove
field theory of
things and have
physics,
proofs that
what
exist
that means for
validly
mankind,
in
or
the
at least
world is
mathematicians,
if you can
and what the universe has to offer to
compactify
help
it to
bring that to the forefront.
geometricize it into
Please
an
take a
actual
moment to like
geometric
and subscribe.
structure. So when something is most pure in all of the mathematics, the most pure of them is geometry, because you can't falsify something with it. It's actual. So when
we should have gone obviously in the physics realms after Newton and gone into the Cartesian's vortexes kind of model that he put out there. So my question has always been, what is spin and what is the torus? Are they the same thing? Are they caused from the same thing? How is this all, working? Because I think the stuff that gets accreted, as they say, I think that's just additional stuff that goes around, like you get for rings around planets and stuff like that. I don't think it actually makes planets as much as it may, I suppose. But I think most of the planets are actually getting made by arcing on the Birkeland currents themselves. So just my opinion.
So speaking of accreting, I did find that article about glass beads sticking together in microgravity due to apparently polarization. So to read a paragraph,
I actually had it up on the screen here. Yeah.
Okay, cool. So anyway, they develop strong electrical charges spontaneously and stick together, forming large aggregates. Now, this is published in Nature Physics on December 9th, 2019. Remarkably, although like charges repel, like charged aggregates form nonetheless, apparently because the charges are so strong that they polarize one another and therefore act like magnets.
Yes, I saw that.
What is it that's acting?
I had actually
unintentional mic drop.
I know. They're basically saying that, and even though that's a kind of a terrible way of actually saying it, they're sticking together, even though they shouldn't. Much like
it is a terrible way to say it.
It is.
You're right.
Like, it's actually static electricity in a nutshell, but it's unfortunately in a nutshell. It turns out it's more like basically electromagnetism. But if you saw what's that planet called? Sedna?
Nibiru?
No. Ultima Thule. Ultima Thule. I type that in, and then I go to the images.
Thule, I think.
Now, it also, if I'm not mistaken, has 5 satellites around. No, 3 satellites. It has 3 satellites around it, and it's a barbell-shaped object. Well, the reason that, as you can see, this is the first thing I think of. Like, this doesn't have enough gravity to actually do what it's doing, to hold these.
You're not sharing your screen with us, by the way, Neil.
No, I know that. I'm trying to keep my load down, but I still end up screwing up. Apparently, they could hear everything.
You said load.
I know. But it's because I have such a load on my duty cycle. Anyway, okay.
Please, more about Neil's loads.
So the point is that this object obviously looks like 2 objects that have merged together, or one has been sort of barfed out of the other one, but didn't quite get all the way out. But that's kind of like when I think about what the glass beads themselves stick to each other. Even though they said, although like charges repel, like charges aggregates form nevertheless, and that's likely because of that likes principle we were talking about, where you have you have 2 objects that are the same charge, like let's say 2 planets, Now, they should repel off each other, but for a moment, they'll actually catch around each other. And of course, we would say that's gravity pulling them around. But there's another force that happens there when you have a positive charge and a positive charge. In between those charges will be a large negative charge that will form, and it will sort of grip them. Now, I'm probably going to apologize for everyone because my apparent audio is being such terrible, terrible things. I'm going to try to do the preview again. This time, not letting it overtalk everyone, because apparently I did that. Terrible. But I'm still blown away by that. Like, that was a perfect line. I was sharing video of the experiment from 2013 where they were in the ISS, where they were showing how they made like DNA strands and other things like that out of the charged particles in 0G. Anyway, I didn't know that was so boring to everyone.
About yeah, you talk about the shape of the odd dumbbells, not symmetrically shaped asteroids with two dumbbells at the ends of it. That reminds me of what's right? That German, not German, the Russian name for that weird. And it spins and it flips back and then it flips back over and over. That reminds me of that shape. That motion reminds me of that shape. You know what I'm talking about?
What, the wrench that was spinning in space, James?
Well, they were in that Russian spacecraft and they spun that thing and then it flipped back over and over on itself. That reminds me of the dumbbell shaped of these things. There seems to be some kind of force putting those two together, but they're flipping each other. It's in a torus form.
Well, they're finding that these planetesimals are a lot of them are shaped like this. Comets, planetesimals, asteroids. Yeah. They're all being electrically etched at the center, and that's why they look like these dumbbells flying around in space.
I'm wrong, by the way. As a
result of having two dipole fields.
There is actually 1, 2, 3. There's 5 satellites around Ultima Thule.
Jeez.
Well, you got to go with your first thought there, Neil. You said 5 to begin with.
Well, I just counted them. They're
only 5.
Yeah, only 5 around something that doesn't have enough mass to. I'm just looking at pictures of it from.
That's freaking crazy, man.
Well, it's almost impossible, it seems, but.
Well, it's impossible with gravity model, but it's perfectly fine with a torus or whatever you want to call it, the spin that seems to be the real thing that's shaping things, that's really making the motion of things. It's because it flips back and forth on itself.
Welcome to the February 9th edition of the Electric View. I'm Neil Thompson. Today we're exploring the unified field theory of physics, what that means for mankind, or at least mathematicians, and what the electric universe has to offer to help bring that to the forefront. Please take a moment to like and subscribe.
If you had
the handle.
If you had like a pile of gravel that was trying to do that in space, it would not want to stay in that formation. It would want to form into a formation more like a dumbbell, no? Just based on just inertia and gravity and stuff, without even pulling in. If you're just saying, oh, it's in a vacuum where there's no electromagnetic field required. Just the fact that this thing's flying through space and rotating around, it's not going to want to stay on that 3-axis because it's going to. One of those odd flips that it does in the middle of the regular rotation, where it goes on that other axis for a while and then flips back again, one of those is it's going to try to orient everything that makes up its mass to stop doing that, I would think.
Yeah, I think you put your finger right on it. mathematically even. The question is the torus the natural form of the motion, or is it cause or effect?
I think the torus is a result of the poloidal field's behavior. And the more I look at more stuff, the more it looks like that to me.
If I might interject something here, I think the torus is
any interpretations.
I think the torus field is a result of a Birkeland current passing through all matter in the solar system, including us. We have a torus field. We have a Birkeland current, which is called the Kundalini. And they recognized it in the ancient past that we have this thing connected to us from the planet, that's connected to the planet from the sun, that's connected from the sun to the galactic arm, that's connected to the galactic arm into the galaxy, and so on and so forth. I think that they generate that action of that Birkeland current passing through any matter generates that torus field. That's what I think.
I think the question is does it come from the small to the large, or does it come from the large to the small? And I think it comes from the I think it comes from the small to the large.
Really?
I think it's coming from the
spirals outward.
I see it the other way around. I see that the material from, if we see a high redshift from different quasars, and we see that this is likely caused because of material not being like electron density or material density or even ion density inside of the plasmoid that will eventually become a galaxy, then
well maybe it's doing a double take. Maybe it's going from the small to the large, but then there's a reaction. The large comes back into the small. That's where gravity comes into play.
Correct. It could be doing both, and there could also be a matter-antimatter equilibrium trying to be reached in certain places too. And this is another thing that we cover. Well, we don't really cover it, but we talk about it very briefly in my talk with Eugene. By the way, I don't know if you want to play another YouTube channel's video or something like that, but by the time this conversation's over, we'll probably have it up live. Or maybe I could set it up so that when this conversation ends, we could just premiere it right at the end of this.
Oh, just show it. Yeah, we'll make it happen.
That would be awesome. So yeah, I'll see if I can do that. It's probably finally done encoding now. I got to get back up on the PC as we're trying to cook chicken here at the same time as do about 18 other things.
Well, I understand completely. So,
boneless, skinless thighs. I'll give you the recipe.
And that's another thing that I think my lady talks about, the current being actually a flow of 22 different flows. And I think the what's on the Earth is just one of not the whole 22. And so we're all looking for this what we call current on the Earth in space, and it's not that, it's something else. And it's something more, and it reacts and acts differently out in space than it does on the Earth.
Yeah, I've been thinking about that quite a bit recently, James, and I'm thinking that there are like Terrence Howard and Buddy and a bunch of other people have the puzzle pieces almost figured out or figured out, but they think that it's just that puzzle piece will unlock everything. We have to get somebody and minds together to think that, wait a second, there are a bunch of different energies down in the quantum realm creating, doing everything that then expresses into a larger field. I think that's the key, that we need to be looking at that and a way to figure out how everything molds together to create the universe the way we see it.
I think Buddy's stuff is like I want to go and jump over on this site and say, where are those 22 flows? Where's your diagram that shows that? You know, so
she may be onto something too, but she may not have. Like again, I'm getting these feelings coming in from somewhere else, and it may be telling me that I'm on the right track in my thinking, but as her, she has a specific number. I don't know how she arrived at that number. That might be wrong. I wouldn't.
Yeah, honestly, after studying my work and looking at the rooms that are built and prepared for us, which is part of the kingdom that we are already stitched into, when you look at them, there is what would seem like an infinite amount of rooms or an infinite amount of channels. When you get to the 33rd gate, a lot of strange things happen, and it happens to be the focal point of a very important lens that people call particles or Higgs boson. And this all material in the whole network goes through these certain nodal points, and they're aggregates or information centers, disbursements or banks where the akasha is recorded, and the wave field, or where the wave field collapses, if you want to believe in that, because that's indeed what's happening, or similar to what's happening.
This is very interesting.
Well, when you really get into the geometry of it, the rheology and the rheometry of it, you can't really nail it down to 11 dimensions or 12 dimensions, and you can't really put
That's a mathematical thing and a logic thing, so we don't have to worry about that.
Right.
I mean, it's a mind game. It's something that you play in your head. If you think about, if someone sat down and gave you the 11 dimensions of reality, it's actually like something you can look up online in the mathematical description of 11 dimensions. And when you go through them all, it's all just explained with lines and dots, so it's real easy. And it says, okay, now if you had to go into a different parallel universe, now that would actually be blah blah blah. Now you're in the 7th dimension, and I was like, oh god, okay, and it was a lot of fun there. But it's still a mind game, and you just basically.
Well, I just say I'm glad. I'm to that kind of thinking. I just said I'm glad you figured it out.
Well.
I'm happy for you, but there's a hell of a lot more to it than that. Yeah, it's basically entertainment for a lot of people.
Yeah, and he's got it figured out.
Let's step back, though. One of the things that I have,
Rick is right.
One of the things I have a concern about is what powers this whole system. And when you're dealing with, for example, atoms and molecules and stuff, we obviously can see how they chemically bond together, but we're talking about what makes a proton, and we haven't really figured that out yet. We have some sort of weird quarks idea, and we're making shit up about what's going on inside of that proton, inside of that nucleus. And obviously the structured atom model really has heralded good grounds there. But what I'm beginning to see is it's not unlike planetary accretion that we're seeing with those beads, where we're seeing them put together. Even though they're all positive charges, they're still managed to glue together, likely because there's some negative charges holding them in there. But still, this gives you the apparent neutrons and so forth. But then we have fields of electrons around them that sort of interlock with each other. And these fields, because of the strength of the electric force, which is incredible, that is a force that links a piece of metal together, so that when you try to twist it, all of those pieces of electrons are going, nope, we're going to resist that. And that's how you get a strong piece of metal, or how concrete is so strong, or whatever.
Yeah.
So when we're looking at things that way, we know that they're not being powered per se, but still the structure of the atoms themselves, the nucleus, presents itself in a way that it can interlock with other materials, forming chemical bonds, and these things are incredibly strong, and they sit there. This is not unlike we were looking at that thing where you can sort of lock magnets together so that they sort of have like little gears that roll around each other. And I thought that was obviously very interesting, but it's similar, and it's using that same like nondescript power. Like the magnet itself has a field around it, and I've heard so many Wheelerisms, and I can't believe I just friggin' turned that into an adjective or verb. But the thing is that it doesn't flow.
Wheelerism?
No, the magnetic field is not flowing. It is embedded into the structure of the material that making that magnetic charge, and there is a counter to it being generated, which is why there's 4 poles to a magnet, one stronger than the other. You only need a little bit on one side for this thing to act as a magnet. When we make super powerful little tiny magnets, then you need a lot of them spinning in the correct direction, to be aligned in the correct direction, so that it facilitates this spiraling motion and creates this magnetic field. And that's sort of like a secondary effect to the electrons themselves doing their work as a quote unquote spiral. Now, this is the trick. We don't know what's really going on there. Looking at things now from a locked point of view, like I was just describing, where every sort of atom is sort of a shape that is interlocking with other atoms, sort of like viruses, actually. And that's what makes molecules. Now, sometimes when these things are aligned correctly, they allow the electrons to sort of have a curve to them that facilitates or makes a false, we'll say, spiral. And with that, because it's not really it's not like an electromagnet where you put amps in a spiraling wire, and that's going to create a real friggin' magnetic field. But you do with the parts of the magnet itself, the little ones, you're actually using its static field as something that you can try to change, and by doing those type of changes to the magnetic field, you're actually begin to move the magnet around by using electricity, and that, of course, is the beginning of electric motors and so on.
Right.
But that's when you actually have to start putting power in, because you want to get movement out, but the field itself is static, and all of that whole discussion is not even touching on what the fuck is gravity and mass. That's just the shapes fitting together, if you get my meaning. And and if you don't mind, I'm giving credit to you there, buddy. When I try to look at these things now, I try to see why the shape is doing what it does, and what makes these things make this power, this almost seemingly magical power of taking charge and turning it into magnetism. And that's
and shape and specific shapes for sure, and how charge radiates into certain specific lines of force, ley lines of force. Go ahead, Richard.
Right. I just wanted to take Neil back to where he said we don't know how a photon, or a proton is created. We have a pair of theoretical physicists in the 30s who we might have half of that problem solved, who have who theorized that that an electron is 2 photons, and we now have the will, or we don't have the will, but we have the technology to make the experiment happen, to take 2 photons and create an electron. If they did that experiment, that would open a whole new door to how this universe is structured and created. Those 2 guys in the 30s, I think they were onto something, because that resonates with me. That when I heard that theory, I went, whoa, because we know that if you take a ham radio antenna and you pump a whole bunch of power through it, what happens? it starts to glow. It starts to give off photons from the electrons that are in the air around the antenna being highly energized.
Well, yeah, but no, Rick. And I'm only going to state this because I think that you're in a misconception here. Even radio waves are photons.
They are photons. Yes, exactly.
Right.
Those are photons too.
Right. Everything's a photon until
every wave is a photon,
changed
or every electromagnetic wave. Except,
right, everything's...
Well, actually, even when you just heat up a piece of iron or whatever, it's...
Well, I've theorized if you walk into a door, close the windows so that there's no light coming in, shut off all the light, you're swimming in photons still.
Yeah. Just because you can't see them, that just means your eyes can't see them. They're passing right through your body. They don't give a crap. Certain frequencies too. Neutrinos are obviously certain frequencies. Gamma radiation from the sun, even though it's small, are still going. It doesn't care about you. Your bones are not thick enough to stop it.
That's just crazy to think that it goes through. That
neutrinos go through all of us, layers. No matter how dense.
It's like, I'm just going to go through the grid. I'm going to make the grid as I go through.
Neutrinos pass through our planet like it's nothing.
Hey, if you were listening, you would understand. Nintendo's pass through everything.
The illusion that we have is caused by the relative. The hardness of things. They're trying to make metals a hardness or particles a hardness or solidness or whatever you want to call it. It's an illusion. It's in motion. It's going. They move. They come and out. They don't stay in any one particular place. Kind of like stars in the galaxies. They can move around individually, but their arms all move together. And an illusion of being solid in some form or fashion. Now, the question is, getting back to your question, Neil, is that where's that motion coming from? And I think it's coming from the whole cosmos is shrinking, getting very, very small, and expanding really, really fast, really, really quickly. So it's really
it doesn't collapse
all the things
all the way. That's sorry to interrupt, but I agree.
Goes really small and then really big, really fast, and it's that kind of motion coming in and out. The question is, can that kind of motion coming in and being really small and then really big and then really small and really big, so fast that you can't perceive it, that
you're talking about photoluminescence,
torus motion itself, or spinning, or what's causing the spin or the torus?
Well, that's actually probably the easiest thing to understand to me. Is you get, anytime that starts to happen, that torus is a definition of a right-hand rule. You have to have a torque to one side. This is not unlike gyroscopes. When you push in one direction, it goes in another. Well, and to a right angle, to a 90-degree angle to the force that you're applying. That gyroscopic motion must be inherent in reality. Must be inherent in electricity. It must be inherent in magnetic fields, which we find it to be generally true. If I have an electron plowing through a wire, we'll call it, the electron itself is moving quite slowly. It makes a field circuit. And that's the most important thing to understand, that most people are not grabbing in this whole thing. It's not just what the electron does, it's the field that the electron generates in the circuit that it's in. And the circuit...
I think...
Go ahead.
I think you're right on, Neil, and I can paraphrase it with this. William Thomson, the British physicist, Lord Kelvin, is most known for his works in thermodynamics. He also turned out to be one of the most ardent supporters of the Vortex Theory. And Thomson argued that from any galvanic current, there extends a moving spiral that coils about the axis of the current. He proposed that the current itself consists of trapping a segment of this spiral and a ponderable matter, matter that has weight. When extending this idea to light waves, he believed the transverse vibrations of the particles of the moving spiral caused the light waves to propagate. Or like Ken Wheeler talks about, they don't propagate, they don't move, they instead perturb, the perturbation. So
there
Yeah,
are
that takes me back to-
similar names for the same thing.
And
I
that
think,
takes me back to Jim's video that he just gave us, those 2 videos about how the Birkeland current splits off into a smaller Birkeland current and propagates 90 degrees outward through the spiraling Birkeland current itself.
Yes, the Hall effect. The Hall effect. It runs the universe in many ways.
It's like when I saw that, I went, "Whoa, he's on to something."
Well, and this is
that's exactly
deal.
the same. The same is true when you look at the vortexes and the drawings and the illustrations that I've shown. There's not only 90-degree propagation, but there's also other degrees of propagation, degrees of freedom in the vortexture of the network.
See, when you're seeing the currents themselves, starting from, we'll just use the term galactic currents because technically there's one for the local group and there seems to be one for the entire superclusters. So
I'm still trapping on the term vortexture.
I know it's such a nice merger, isn't it?
Vortexture.
That is
it's going to take me a minute.
I like that.
Well, wait till you hear the term vortisphere, because vortisphere is where it's at too. I mean, it paints the whole picture.
Oh, God.
However, before
That's
we
awesome.
go a little bit crazy here, obviously vortexes being in 3D, if there is a toroidal motion to light, which there seems to be, then as we've discussed before, it implies a speed faster than light automatically by the virtue of the fact that it exists, because it's not just a wave traveling on a pond. It sort of has a torus loop that's sort of folding back in on itself as it travels and sort of gets bigger as it goes.
Even a wave on a pond has energy that's much like a spiral if you actually look at the energy, because the matter that's moving around looks like a wave, but you can't analyze a wave on liquid like on the Earth. It actually does kind of propagate a little bit like a spiral. And believe me, I'm not a Birkeland current acolyte.
Well, I'm not. What I was seeing, I'm just referring to strictly from a mathematical construct of the torus going through. You're going to have a speed faster because it has to go not straight. It has to go off to one side at 90 degrees, and therefore you add pi to the equation, and you can begin to understand that it has to go faster than the speed of light. That motion.
Well, a torus spinning produces a helix. It produces a leading trail and a trail and a ending trail of a torus. There's a beginning torque that when the torus spins, it literally, the science of this is all written out by Vladimir B. Ginsburg. I can't direct us enough towards his attention because he literally laid it out, and it's beautiful. He shows how there's superluminal and subluminal velocities inside of the torus, and each torus on the inside of the rim is superluminal, and on the outside it's subluminal. And so on the inside, there's these cavities that are creating the perpetual motion as if there's a forest of Hopf vibrations. So the geometry of this is coming together very much, and the conversations that we're having are exactly the kind of conversations that they were having with Lord Kelvin and the Scottish physicist Peter Tate, and who was working with Helmholtz, and the beginning of all of the electromagnetism. They were also working with James Clerk Maxwell, and they postulated that it was first they all wanted to try to describe it using a vortex, and because you could observe it, you had a real world working model. But then they had to change James Clerk Maxwell changed his 3 different times and broke away from Lord Kelvin and Peter Tate's model of the vortex and created his model of the electromagnetic wave, which broke us away from the vortex and not thinking and toroids and things like that. But one person that's very least or seldom researched is the physicist Peter Tate, because he shows working models of the toroids, and if you look up his toroidal vortices, then you can see that what he was working on transitioned into our understanding with James Clerk Maxwell's model of light and light being a wave. So once again, and every other time throughout history, the vortex has been the center of us trying to understand the dynamics of what's going on. And I just wanted to say, I think heavy water, how we discovered what neutrinos were, was discovered by Walter Russell as well, heavy water, and that's how he earned his doctorates, by predicting that heavy water existed.
You mean deuterium oxide?
And transuranium elements. So we got the atom bomb as well from him predicting that the elements existed before we knew them.
Look, I will not tolerate that kind of stuff against elements. If they wish to be trans, they can self-identify that way. That's up to them.
You are militantly for trans elements. This is the second time I've heard you just laying down the law, man. I mean, I don't know. Are you some sort of an anti-matterist?
Explosively so. Sorry.
You know, I wonder what Maxwell would.
Don't even get me started about dilithium. Don't even get me started. Anyway, go on. Sorry.
No, I just said that. I was wondering what Maxwell would have done with the plasmoid if he had it.
Well, Maxwell had his hands full just trying to understand the statics of plotting static fields. Daniel, your mic's open.
Oh, sorry, man.
And the static field of and then plotting that by hand. We have the advantage of starting to use some of that, even though we knew mathematically what it was going to do. We couldn't believe the results. One of them being, of course, hey, I have a great idea. I'm going to use a magnet and some phosphorus. I'm going to shoot an electron beam at that, and I'm going to light that phosphorus up, and I'm going to do it friggin' 30 or 40 times a second, and so fast you won't even see it. Now, I'm blown away by the fact that even works. Like, that's alien technology. That's how I couldn't even envision doing that. Radios, I can figure out. Okay, in my head, I know how a radio works. I could build one. Okay, I couldn't build a television. That blows my mind. So when I'm sitting here looking at that, I mean, I'm sure if I put my mind to it, I could probably figure it out. But it's just an amazing piece of that we use math to figure that out, and it works. Well, even though you can't see it, even if because I mean, when you do stuff with electricity, it's one of the few engineering sciences where you're working all in your head. Like, I can pretend that I know what 15 nanoseconds is, but you don't. I don't know that any more than I know what a million years is, because it's so small a time frame. Now, I can do the math and figure out how many of those is going to be perfect and how many I need to fit into this, and it will work. But it's still playing with reality on that scale. And when you start putting that now into going all the way back into trying to figure out circuits, and in the realm of cosmology, you start looking at the galaxy as a load on a circuit. And then, of course, now that there's a field, there's a CMF field, or a counter magnetic field, a counter electric field, that are going against all this, that are being induced and charged up because of the motions of the electrons going through this twisting load that is a galaxy, through the plasmoids that are constantly being powered and crunched down by this field. And now looking at the force-free idea, or near force-free of a Birkeland current, then suddenly being drawn into a magnetic field of its own creation as the load gets heavier and heavier. And then
our habits form like that too. Our habits are most likely to form in a force-free field-aligned current. If you're on your way doing something and you want to do something else, your best bet is to do it while you're on your way towards somewhere or already up and moving.
Well, I was just going to say that not only is everything included in that one current, but suddenly all life and all that is being powered by this. It's impressive and awe-inspiring, because now we have to sort of come to a new understanding. I mean, once you start coming to a new understanding of gravity, you have to understand, well, what's powering gravity? I mean, something's pulling on something else.
Well, we also have to come to the understanding that the pre-Socratic philosophers, the natural philosophers, were correct. And we haven't gone anywhere with metaphysics since them. Pretty much, here we are with the same spot in the same spot.
Yeah, that's interesting.
Well
but we do put a link of Tate on for other people to jump on in, and it's really interesting. We do know what gravity is coming from. It's the inverse of the cosmic charge. So that's how it's related. The problem we have is that with this hardness, this solidness thing, keeps us from being able to comprehend mass. So yeah, that's my take.
Well, I don't.
That was wonderful. The inverse of the charge. That's exactly what it is.
Yeah, I've never heard it put so succinctly.
Well, my belief
Great job, James.
is that matter is just energy structured into elements and then ordered into groups of these elements that then create gases and solids and liquids, period.
Well,
Markland convection. What is Markland convection? It's nothing but being on the outside of a cylinder. So it's cylinder dynamics, which is solenoids, and solenoidal science is the science of how waves move, frequencies.
Well, there is I mean, it's a cylinder, and there is a convection to obviously pull things into layers. And we can see that different planets are made different ways. The shape of their magnetic fields and the strength of them are different. But when I start seeing how they interact, I'm still trying to go back and understand how, like thinking back to the grand unified theory, even though they might all be different waves, what makes protons special? Why are the positive charges able to gang up inside of a nucleus and form different elements? What's going on there? Now, I think that it might be I mean, right now, I'm still of the opinion that seeing negative charges just appear out of nowhere is not a big deal to me now. I mean, I'm seeing now that if I bring two positive charges together, I will get a negative in between them. And it'll happen no matter what. It's almost like it's pulled out of the ether. The only question is, why do electrons have any mass whatsoever then? How is that happening? So if that's the case, then there has to be a relationship between electrons and mass, which might be exactly as simple as it seems. that there is a difference between electron charge and the mass difference, the mass of an electron itself being as minuscule as it is, might be literally all there is to the different. I don't even know if that's equivalent to the charge potential difference of gravity, but still.
Yeah, I think you're touching on something important here in that you can look at one object and say, oh, it moved, therefore there's another object there that's pulling it there. So is it another object, or is it simply a charge floating around? You know, so many things that we're measuring, whether it's in cosmology or whether it's in the subatomic world, we're not able to see these things. We're assuming that they're there because of their effect on other things that we can see, right?
Yes. And it gives us the apparent gravity. And of course, some of this might be that our gravity field is not as uniform as we think it is. Like, I keep thinking about the fact that over the poles of a planet, gravity might be different. We don't have a lot of polar things. We're just now doing one to the sun. So
it is slightly different because of inertia, I guess. Aren't you slightly? Isn't your weight slightly lower at the equator than at the poles?
Well, no, I'm not referring to the actual gravity of the planet's surface. I'm referring to further out. I'm trying to understand gravity anomalies and flyby anomalies, stuff like that. Like, why are they happening? What is the nature of them?
That would have yeah. All right.
Anyway, Duff, Rich, can you you mentioned the people in the chat. I was hoping for an opportunity, and this is as good as any. So get to it.
Absolutely. There's lots of lively conversation going on in the chat. Joao Benjamin says, is acidity a magnetic or an alkalinity gravitational? Which I thought was an interesting idea, combining these two ideas, acidity and alkalinity being magnetic, related to magnetism at all.
They're electric, Duffy. They're actually electric. They're expressed in volts.
Yeah.
Well, that I did know, that there is a certain amount of material inside of it, and I think acidity is negative, right?
Yeah, acidity is negative. Alkalinity is positive.
I don't know much
never
about
understood
it, so
that, and I know you're supposed to have like one of the two in your body, and you're supposed to balance it with lemons and limes, and you have a lot of that. It's good.
Exactly.
And it fights cancer.
It's an interesting association, and I think it's worth bringing up. Black Law says, will humans beach themselves like whales if their electrical or magnetic field is disabled?
We're already doing it. The United States, the suicide rate of men that used to not commit suicide is like skyrocket. That would be
true.
the 50s bracket.
I've been reading those statistics.
I don't mean to make fun of, but how could the people used to commit suicide? Isn't it just you only do it once?
Well, I don't know.
It's a one-time deal.
But yeah,
it's a one-time deal.
It's all across the board. It's all across the board.
I kill myself a little bit every day.
I kill myself a little bit every day.
The little death. Okay,
I die a little inside every day.
It's just once a day. It's all I need.
Any more questions, Duff?
Yeah, Renegade says matter is dielectric condensate.
I agree.
Agreed? Do we agree on that one?
Is this a Jeopardy?
No.
What is yes?
I don't know what dielectric means, except for like something that cannot have electricity. But
all life sustaining forces are dielectric. I think like that.
No. But dielectric means the ability to stop charges from traveling across it, and obviously, copper, although allows charge to go through it, is not.
Excuse me.
Is real, like it's material. It's a real thing.
So one of our guest name is going by N, And N says, a point has no dimensions. A line is made up of points. That's where the madness started.
Goddamn geometry.
It's Euclid's fault.
I picture someone in grade 4, just like a little kid in grade 4, flipping the friggin' table over, just like his whole desk. Screw geometry.
I would
There's
say
got to be a better way.
To that statement, add Lucy in the Sky with Diamonds, and you're almost there.
Ba-da-bump.
Keep going.
Renegade says time is a measurement of entropy. Entropy is a variable depending on the environment.
Time is a measure. I watched a Doctor Who episode about entropy before like this. But to imagine that there's that entropy is one of those situations that is a part of the mentality of the Big Bang culture, or the Big Bang paradigm. It's the creation, destruction, the Big Crunch. That idea. Are we just going to is everything just going to heat up and we all going to die, or is it going to be everything going to cold and we all going to die? But this is all sort of like metaphysical when we began to realize now that there's a reality. And the reality is that creation and destruction are occurring inside of the same galaxy now.
Also, inside of every wavelength, I think you can say the same. There's a life vortex and a death vortex leading from point to point.
Yeah, creation
one
events.
is implosive, one is explosive, one is entropic, and one is negentropic.
Well,
creation events and destruction events happen every day in the universe. It's nothing new.
So P Turtle says, I'm trying to suggest that the universe folds in on itself in a toroidal shape, out and back into the singularity. Could space-time curve be explained by a torus universe?
How about there is no space-time curve? Everything's in XY coordinates. The galactic center is not a singularity but a plasmoid, and yes, everything does flow in a torus around that, which basically goes out the arms, comes back in along the poles.
And everything is hollow. The center is hollow.
Well, I guess in a plasmoid, I don't think any matter could possibly contain the amount of power the galactic plasmoid has. Get my meaning? So,
because we're in an open system, it's not a closed system, so there's a lot of energy coming through from the circuit, from wherever. So this entropy idea is part of this closed system way of thinking, where we have to account for all the energy, but maybe we've missed out the all the stuff that's around us all the time.
Right, and I think a good example of that would be the fact that there is a large amount of atmosphere escaping the planet every single day, and the amount is replaced. So that implies an open system as well. So we're not as scarcity driven as we think on the atmosphere.
I agree.
Yeah, I think that a lot of that finite thinking, and to be fair, that the people who came up with this at the beginning, especially when you start isolating yourself from natural philosophy, in a natural philosophy kind of way, these ideas were just forgotten, and if you start. Because we started focusing on and specializing in certain things, and cosmology forgot that it was a thing to study, and it started studying the things, if you get my meaning. And one of the things...
Final comment here.
Because I'm just going to finish, is that each of the things became points of light to study, if you understand my meaning. The planet was just a thing, separate from everything else.
So they were separate.
Yes.
They were separate thoughts and separate entities
Yes, and we've lost, and that lost the connection. But it wasn't right up until like 1910. We were still holding on. There were still people who were going, no, there's charge here, and there's a flux traveling, and people are like, what? But those were almost ignored after Einstein. It became the big kick, and once an entire generation forgot that they even thought that way, it took people it took until what, the 80s and 90s before people were going, like Wal Thornhill and stuff, were going, yo, hang on a sec. We forgot something. We forgot it way back in 1910. Can we pick that back up now? You know?
Right. And Russell was like a bridge between the gap, Walter Russell, between the layers, if you will. If you start
he never
thinking
lost
in the way
about
the
patterns and thoughts about vortexes and
natural philosophy, right?
Well,
he was
that's
very
what I
much a
mean.
natural philosopher.
And even though I don't agree with him on many things, I do agree that I would not stop him from his thoughts, if you get my meaning. Like, please continue thinking, sir, because your thoughts will... I feel you're going to see a truth to the universe that we've all forgotten, and we should pay attention to people like that sometimes. I don't mean go read every Edward Casey book or anything either, but you know what I mean.
Well, I'm since Duffy is finished with all the questions, I'm about to butcher some names here, if you don't mind.
I actually had, I think it's important to mention that in the Skype conversation, Pisces made a comment that I thought was pretty pertinent as sort of a final thought. She said maybe the view of dielectrics as dead matter in our junction point of departure in terms of quantum disentanglement from the mainstream view.
So dielectrics equals death instead of life?
Dielectrics equals mica to me.
Well, if it's related to entropy, yeah, then I would say so.
Like Neil, when he says something that us electrical unnerdies would appreciate a little example of what that really is. We're all dying in terms like solar wind. We're drowned in all this stuff with these paradigms that keep us from moving forward, because we use them because we have to label it something. We have to put.
Well, and it also doesn't help that when you were talking there earlier, James, you said, "Is that a condenser?" And I was like, "Yes, that's an old name for a capacitor." That's all it is. It's like Tesla. If he uses the word condenser, it means capacitor today. That's it. Like, and it's the exact same thing. And the trouble is also that the standards weren't down pat. By the time 1960s rolled around, or 50s, everything was laid out in standards, and I could read anything from that period forward as a technical schematic, like for the blueprint for, say, a power plant. I would understand what I was looking at just by,
Yeah, but even though there are other people who don't know what a power plant is, or what they would, appreciate a real named thing that they know exists. Is the Earth a capacitor or not? Is what's holding the load? What's just a small, obvious, little thing that they know of is this thing that we're talking about. And when we're talking about solar wind, we're talking about a whole paradigm. And when we decide that paradigm isn't real anymore, and we use those terms, we're putting ourselves in a loop that cannot be solved. We have to use some kind of terminology that frees us from these false beliefs and ideas that are just you can't, even when we understand how it works and we use their terminology, we doom ourselves from being able to be clear and understand. And even unconsciously, we are still holding on to these things, which makes it impossible for us to disentangle ourselves from what we know is wrong or doesn't work or whatever. If I keep on using terms of hardness, I'll never get out. I'll never even find out where Maxwell waves is work. Maxwell and his waves and fields actually did function and did work and is valid. And once I start using atoms and particles as my metaphors or whatever, I've just blown myself out of the water. I can't communicate anymore to anybody clearly about how things actually work.
Now, this is actually perfect, James. You just identified the common thing in the grand unification of physics, because you just basically are talking about going from Maxwell's equations and fields to, and you said particles and things crashing into each other, which is basic physics, classical mechanics. And that bridge is something that we do. Like, it is probably right now the biggest bridge that we're linking. I mean, Tesla motors, for example, is where you're starting to realize if we can generate the electricity efficiently, then suddenly we're not wasting all of this energy on waste heat that this and friction that the engines make. You know, because our engines are relatively inefficient. The only thing that makes things good is the amount of power we get from the gasoline that we have, which is monumentally powerful. Just really compressed energy-wise. Now, when we're looking at this and seeing, like, I apologize, number one, I'm very sorry about not stepping up and giving people examples of things as much. And feel free to continue to call me out on that, and I'll attempt to address questions as we get them, because I want people to understand. That's more or less my goal. So,
can you explain how TV works again?
Magic. It's absolute magic.
I heard you say you don't know how it works.
Well, no, I mean, I know generally how it works. Like, I generally know how a car works, but I mean, I'm not. You're right. When it gets right down to it, it's like, okay, I could read, like, I could read a schematic and tell you how to build it. But I mean, and until you understand what you're looking at, a power plant versus a schematic for a TV, you're amazed at how complex and how some things are really simple. Because a schematic could look really complex if you're just looking at certain things as just a motor as looking at a load, as opposed to the actual inner workings of the turbine. Now that's a whole different ballgame. But what it looks like to the circuit on the outside is just this. It's very interesting.
So can I point out that we have 75 people watching live now?
Wow.
Mm-hmm.
Fantastic.
Please like and share, folks. Get more of your friends and families on here watching this stuff if they're interested.
So do we have any more questions? Or?
Well, I'd like to just say hello to the folks first, if you don't mind.
Feel free.
All right. Frederick Rhodes, P. Turtle, Adam K., Yael Benjamin, Christian P. Norris, Hallie Caper, Electric Origins, Stephen Sherrill, Cole Panacci. I'm probably butchering names here, but sorry, folks. St. Louis Arch, Fiction Bull. Yeah, okay.
And it's one of our viewers.
Ronnie Cassidy. It's probably maybe endearing or the opposite to some people, but anyways. Esoteric Gold, Jay Armstrong, Dendrite XI. Mind Over Monkey, is that it? Oh, that's a good one. And welcome, everybody. Praise Y. If I missed anybody, My Dirty Videos, that's a good name. Welcome. And Black Claw, welcome, everybody.
Love that.
Hey, Neil, I'm not going to jump in and interrupt your flow of stuff when you're going, but if you start saying things and don't put, small little images or examples of what those are, I'm just going to hit surprise on mine so that you know.
I'll do my best then.
Robert Diggins and Mary Oliver, hello. Welcome, everybody.
Well, that's fantastic. So yeah, we were.
Yeah, thanks for tuning in. So many people.
I know, it's so nice, and we don't have a chance to talk about things like this nearly as much, especially trying to understand what a new unification of physics would be, moving from, say, the grand unification idea of physics, which we were talking about earlier, or you had mentioned with Eugene Bagashoff there. And of course, that includes relativity. But moving now from the plasma universe is a lot easier because you haven't left EM. You're still there. The trouble is trying to actually figure out and map these circuits. It's sort of like trying to draw fire, And I don't mean draw fire as in shoot at me. I mean physically draw fire with a pen and paper.
Well, that's a problem in itself because the mathematical models are just, they're models. They're not necessarily physical models, and they don't have all the models. And why would we depend on math as being, being able to model things with math? Because we don't have them all.
Exactly.
And when gravity came in with Newton, he made a new math in order to make it. And we're going to probably have to make a new math. And if we do, I would suggest base 12 because that makes the radius of things a lot easier. The same.
Well, base 12 is the same or similar system to the ancient Sumerian base 6 system, which expresses small numbers way better than the base 10 system, and way large numbers better than the base 10 system as well.
Yeah, the base 10 is good for detail, but it has a philosophy behind it, and that's what people don't really get.
The way I understand it, James, is the base 10 is more linear than the base 6 system or the base 12 system. They're able to express spheres a lot better than the base 10 system does. That's the way I understand.
And the thing with it is that Rupert Sheldrake pointed out that they just move the numbers, wherever it doesn't fit. They just move the numbers around until they get a balance that they want. That's what we intuitively do, whether people want to recognize it or not.
You're right.
We use our intuition to say, okay, this piece, we need 3 pieces. They got this piece, and I have this piece, and I have this piece, and therefore that piece has to mean to balance out. That piece has to be this, because that's the only way it will balance out. And then they find out that they don't really know about the 2 of them, so they just start farting around with stuff to see whether it makes sense if that was true. And then they forget that it was just a guess in the first place, and now it's settled science, and you can't change it. And you say, well, no, you're one of the leaders. You're one of the guys who's radical, who's a dissenter, who sticks out of the herd and is willing to die for it. And you got everybody else of the followers who are protecting the establishment's authority against the truth. And you're just dying because you can't change anything. We can't move things in the proper direction.
How do you convince a scientist that they're not doing science? Like
when they think they are
when
science.
They think, because your description is basically dark matter in a nutshell. You're basically sitting there going, okay, well, gravity is what holds everything together. Agreed. Okay, we don't have enough mass to hold this galaxy together. Well, there must be dark mass. Excellent idea.
How dare you?
Agreed.
No, agreed. And they just write it in. As you said, that's balancing an equation. That's, of course, they don't even state the assumption. And the assumption being, of course, that gravity is holding everything together. Well, if gravity isn't, then,
Electricity.
Yeah, but it's a lot worse than that, because they're pretending it's a Band-Aid, that the dark mass and energy is a Band-Aid, when in fact it's making the mass that they do exist at 5% an error bar. Now it's the theory of dark mass and energy. It's not gravity, or what you can see. It's what you can't see. Now that's and the question is,
to be fair, we're kind of saying the same thing. It is
we
the
know what they
currents
can't
between
see.
the galaxies, But
sorry, Neil, we know what they can't see. They can't see Birkeland current energy in dark mode, period. And that's what they're calling dark matter. And now they're starting to call it dark energy, right? Down in the quantum level. But I would say that they're going to, in a couple of years, extrapolate that up into the cosmic level.
Well,
dark energy is kind of the explanation for redshift. It's not so much astrophysical as it is on a cosmic scale, a cosmologic, intergalactic scale. It's used to explain the reason why redshift calculations that were incorrectly done have caused people to believe that everything is expanding away from each other at ever increasing velocities.
Well, yes.
I thought it was down to express in the quantum realm some action that was going on down there. But you might be right. I don't know.
I'm not aware of dark energy except in reference to like cosmic scale, intergalactic scale motions. No,
it's supposed to basically be the invisible force that keeps all this dark matter from crushing us.
It's the force that's push. It's the reason why galaxies in the universe seem to be accelerating at ever expanding speeds apart from each other, which is
except for one,
probably a fundamental misunderstanding of redshift or something like that. But back to the fingers of God that Neil was talking about a couple of weeks ago.
Love those.
A common problem, with things like Hubble's redshift measurements.
It still blew me away that you have to go to like I was sitting there arguing with a guy who's going for his doctorate in astrophysics, and he was in his master's at this point, and I'm like, you've never heard of this? No. I'm like, why not? Like,
who gets a master's in astrophysics? Why would you not just go from a bachelor's to a PhD? What's the point of having a master's in astrophysics? That's like having a master's in law.
No. He was going all the way to get his doctorate. He was just in that part of it. I don't know. The not the last 2 years or whatever. But I don't know how it works. He was Australian.
Well, usually in a hard science, you wouldn't go from a bachelor's to a master's. You would just go from a bachelor's to a PhD.
Okay, well then he was somewhere, but he was still not quite in the, like, I don't know how many years, 8 years you take or 7 years. He was still like only in this 5th year or 6th year or something. I don't know. I don't know exactly how it runs, but whatever.
I see. My mute button is working intermittently. I apologize if I sound like I'm delayed on responding.
No, you sound fine.
No, but the dark mass and energy is the replacement for cosmic charge. So,
well, I have the definition here. What is dark energy and why is it important? What is dark energy? We need dark energy to explain why gravity seems to be driving galaxies in our universe apart instead of pulling them together. The nature of dark energy is one of the most important unsolved problems in all of science. Well, yeah, we have the answer right in front of them, Birkeland currents.
No, they're not interested. Go next.
I'm not sure Birkeland currents I'm not sure Birkeland currents explain why the common belief is that galaxies are all expanding away from each other at a faster and faster rate of speed. It's not really, they're kind of not related, I don't really think, in terms of astronomy and astrophysics and cosmology.
Well, if we are expanding, then we have to think of it in terms of the solar system and particles leaving the sun and accelerating out to the cathode.
Well, they're trying to pretend that if everything is flying away from each other, and therefore space itself is expanding or something, that
only on a galactic scale.
Well, let me just finish. This would allow them to say that the Earth, because of that diagram, the fingers of God problem that we described before, the Earth is not the center of the universe if everything is flying away from everything else. Now, this is basically just not admitting that redshift does not equal distance. That's all this really is. All of this could be solved by throwing all of that away.
I agree. That's correct.
Yeah. Well, we know that we're not flowing away from everything else. We're flowing towards a supercluster. In fact,
and
science has got that stuff figured out, right?
Towards Andromeda. That's what it looks like. Yeah. The trouble is that we're red shifted, or Andromeda's blue shifted to us because it might be our parent and has significantly more electron density than we have. Now, that said, we don't know what quasars have for electron density, and I'm using that term loosely. I don't even know if I'm using the term correctly in this particular thing, but I'm trying to...
You mean quasar or electron density?
No, I mean quasar. I know what quasars are, but I meant electron density. I'm trying to use that as a way of saying not having a lot of mass yet, or young, or something like that. Basically, an apparent age as opposed to a distance calculation. Whatever the factor is in there, it's certainly giving us a false perception of the distance between other things if we consider this to be Doppler.
It may be a factor of both.
Well, it could be. But the issue, therefore, is if things are not flying apart, then likely things are cellularly linked together in clusters, as we see, which, if we could see their shells around them, we would see galaxies sort of clustered together like almost like a jellyfish sort of squished together of a bunch of blobs of galaxies sort of doing their thing. And then if we could go inside and look at, say, the environment of each of these stars. Each star has its own little bubble around it, and we are on a ring of bubbles stuck to the side of a tube. That's kind of what we look like. That none of that is gravitationally controlled at all. Only things that seem to be gravitationally controlled is when we start getting our size.
Inside a magnetic field.
Well,
when you're inside a magnetic field, gravity takes over as the most primary force, because we experience it on our body, right?
But we can't, because number one, we can't shield gravity. We can't shield mass. We haven't been able to figure that out yet. We haven't been able to figure out.
I heard someone figured out a way to shield gravity, though.
Well, there's been some 0.2 or kind of changing with gyroscope type stuff, but I mean real friggin' inertial dampener shielding here. Like if that shit was invented, every single car would have it. Okay, because suddenly you don't weigh anything when you're in a car accident. Crush. Oh no, I don't actually impact things very hard. I just get pushed against these pillows.
Right.
Everyone would live.
But I suppose that.
Well, unless you get like
surmise
some sort of
that
like knife going right through the whole thing, or like like
if you
a
build
crane
a ship,
crushed it or something.
right? But if you build a ship and you put enough positive charge around it, that would levitate it away from the negative charge of the surface of the Earth.
Well,
and
we do know.
Then you have levitation.
Well, that's a theory, and I don't know if it's true yet. And the only reason I don't know is because we do know that you can get thrust generated through ionic wind, so you can actually pull material from point A to point B. But what if it's in a controlled type of environment where they're sealed, it's not able to pull downwards? Can you generate enough to change the polarity of the entire planet? It's the idea of then spinning it to make it the dipoles of all the atoms inside the gyroscope point to the outside, a la Wall Thornhill's theory of gravity, then perhaps this could be true. But I certainly don't have the money for that experiment. But if nothing else, this seems like something that somebody else who thinks like me would have already thought of and probably been doing since the 1940s, and then putting up discs and flying them around. But I don't know of anything that was ever seen in the sky that looks like flying discs. So I'm just going to ignore
T.
that.
Townsend Brown in the 1930s developed the technology, and then the military scooped them up. And
this is my joke that is clearly people see them all the time, is what I'm saying. But I don't know if they're the same thing. It's simply, an example of what could be true.
Professor Holt makes an interesting point. They say, do you think there's a shape to the universe, or is it toroidal? And are we going through the part that's expanding cycles?
We're in these...
Pretty big question.
I object in that toroidal is a shape.
Well, okay. If I was to describe the universe, someone asked me to describe it before, I would probably put it in this context. Imagine two areas, one area of charge that is the entirety of the universe and well bigger than what we think the universe is. So, okay, just imagine a space that is infinitely big, like times 2 type of thing. Okay, so somehow it develops some area of charge is felt that is different than the charge that it has, and it begins to build a barrier between these 2 points.
Welcome to Space News.
It would feel them without actually anything being generated. They just start to sense each other. Now, once they quote-unquote touched, a spark would occur, and then an hourglass shape would form in this spark. That would be the entire universe. That's it.
Yeah, that sounds like a logical,
that little tiny spark.
That's not a super crazy idea right there, Neil.
No, that makes a lot of sense, and brings us to Lapointe's work, right?
Well, and what would happen then is the only way that this implies that there's a buildup of charge along this entire boundary between these 2 areas of differing charge, because remember, one area is slightly different than the other, and it will never stay uniform. The moment that one part begins to move, the whole thing begins to unravel, so to speak, and it's going to form a boundary of a double layer between these 2 points. And then once a spark is sort of shot between them, that is the universe sort of draining the charge between one boundary to the next. And eventually it will go out. Now, possibly, this could be forming what's called a giant hourglass shape, sort of like a giant homopolar motor type effect that's reaching back around itself, and it's going to create a sort of a toroidal loop. Now, I have no friggin' idea, because that's so big. I can't even envision how big it is. Okay, but all of the things that we are seeing, that is all these galaxies, everything that we see around us, is basically the sparks of an explosion that is ongoing and has been for as far as we've ever known. As far as we've ever known.
Well, you could envision a toroid or a double toroid, and that itself, if you can envision two of them, that's one ability of your comprehension. But if you can envision three nested toruses, and then 4 or 5, and the higher up toroids that you can
I've already come to this
the higher dimensions.
I've already gone this into weird levels. Like I began to think, well, what happens if there's not just one spark of an area, but an area over to a side that is sort of also sparking, but the light from that other universe would never actually reach us before the sparks are all done. So did it even happen? Can we feel it? Did we know it occurred over there? Is there some sort of sense that our galaxy or our universe can know that that universe existed? You know, those are the questions that I was pondering, trying to figure out. Like long after, as our universe begins to like filter down, and there's only like a few billion galaxies left, you know, and they're all winding down and the sparks are all going out. We would see a very amazing explosion off to our left as we see the birth of that spark that happened so long ago, and of that universe flashing into existence, and that light just reaching us now, hundreds of millions of years later.
Billions.
Well, I'm making shit up. It doesn't matter. I don't know.
But
like it's just coming to the understanding of, oh, you know, like if you zoomed out and took a look. I mean, that's what I try to do, because some of these things are things that you would see naturally, like what does I mean, spheres are automatically made in Z-pinches, so I figure I understand them pretty well, but except that they can form in different ways, and they can be made of different material, and they can be cooked, and they could have like silicates covered over with metals on top, or vice versa. Like, these tell me that these things are not all the same, and
I go back to Sesame Street. Which one of these isn't the same? Which one of these
well,
isn't
it
like
just
the
means
other?
that you can start figuring out the parentage of a planet or a moon, and
Right.
like, is Titan the sister of Venus? There's been arguments of that, and of course, it's been said, even in conventional astronomy, it's similar to Venus. Has a thick atmosphere, it's similar in size, blah, 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 blah. Okay. But it orbits Saturn. No one ever thought that was weird? You know, like it's way over here? Well, it could have been made from the birth from the same planet. Or two planets, Jupiter and Saturn, could have been shooting at each other, and these two things formed. And one went with Saturn, the other one didn't.
Neil, I have a question. What's the formation that our filament is leading towards? The Pleiades?
Well, the Pleiades is the middle of a ring of stars that we are one of, it seems.
And we're locked in a current of that, or what?
We seem to be on the ring current attached to the side of a Birkeland current, which the Pleiades is a former sort of hourglass-shaped middle of.
The Orion spur, one side of it is pointing to Orion, and the other side of it is pointing to the Draco's star group, or star system. That's the way I understand it. On the galactic arm type scale, you're thinking, yeah, we're inside the spur that's off of the Orion arm of the galaxy, and inside that spur we're looking towards Orion, which is close to the spur, where the beginning of the spur is, and out at the end of the spur is the Draco system.
Is there Sirius A and B in there?
Sirius is right behind us on the spur, I would think.
On the pipe.
Oh, okay. So, well, because if we are indeed currents that are induced off of electromagnetic, like if the aurora sings us into being out of sound, like I was talking about earlier in the episode, it would make sense that other living forms and living creatures, the memory of them, we would be collectively strung on the string. So organisms would be more likely to crystallize or materialize into our system from the, you said, so Draco's behind us. So
Sirius is behind us, and Draco is behind us as well, because it's at the end of the spur.
And we're pointed towards the Pleiades.
The Pleiades is in the center of the Taurus that runs from the top of the spur to the bottom of the spur. Apparently, that's the way I visualize it.
The cool thing, if you thought about this, well, hold on. If you really want to see some thought of something cool, is that you know how we have an aurora with the planet, with the Earth, obviously, and you can see the aurora occasionally and so forth. Well, if we could see down the pipe, and Sirius was something that this whole pipe was glowing, especially when the Pleiades apparently exploded, then that we would see an aurora like coming from Sirius that would be surrounding the whole thing, and we would see, looking down it, it would be like a celestial flower, almost like an orchid or something.
Like, for instance, if there's a giant
vessel function.
Well, it could be spiraling. You're right. It could be swirling. Anyway.
If there's a giant filament in between you and Sirius, and it's in severe electron deficit, and then all of a sudden it gets blasted with electrons, it could go from looking like nothing because it's not ionized enough for you to see it. It's not emitting light.
It's not on.
And that's why the
profile is that its emission and absorption spectra are both low enough that you can't get a signal and say, "Oh, hi, there's stuff there." But if it suddenly gets electronized for whatever reason, or even if something just physically illuminates it, also you could suddenly see something that was otherwise utterly invisible.
Something managed to make the entire area glow for a time, it seemed, enough that we drew it on maps.
And we could see it in the sky, and that's why the Egyptians said the gods came from there and left and went to back to their homes. Some of them came from Draco, some of them came from Orion.
I don't know where they think the gods came from on that, but I do know that if you could see it, it would certainly be very impressive. I mean, it would be something.
I'm just pointing to the
eyes.
shafts in the Great Pyramid. They're pointing to those points in the sky, and that's why they say that they're pointing to those points in the sky based on the mythology of the Egyptian text that says some of the gods came from the Draco system, some of them came from Orion, and they left and they went back that way.
That is incredible, because I would think
that would explain it.
Well, I would think that the best place for us to look for intelligent life would be in those origins, those two places, because just of the fact that if morphic resonance is real and sonobiology is real and sound acousts or beings acoust out of sound, then we could be getting the resonance from these. Just the resonance alone would produce the living organisms on Earth from these other filaments, these places, Sirius A, Sirius B, and Arcturus, that were pointed at.
That's really interesting. Thanks for answering that. I'm curious, really curious.
The Dawkins said that there's a satellite around Sirius C, so that's probably the closest that you're going to get as far as what the intensity of the life is. Pi says that we're moving towards Vega, which is in front of us in Cancer constellation. My point is that my lady tells me that we're on the axis in our bubble. If we were actually on the edge of our bubble, half of our sky field would be blank. There would be no stars there at all. So I was curious as to how that would change our perceptions. If being in the center, everything does look, in fact, like it's going away from us.
Well, that's on a galactic or on a redshift level. We're looking at quasars and things that are supposedly very far, far, far away, ejecta of other galaxies, not something around us locally in the star system, because we can technically, I mean, even though Andromeda is in the sky, we cannot see Andromeda. If we could see Andromeda, Andromeda would be like, well, I think it would be much larger than your hand at arm's length. It would probably be larger than a basketball. But it's a huge object, but it's so faint. You'd have to be able to take a long exposure picture to take a picture of the of Andromeda. Now, we can only see the light from stars in a very small radius around us, probably only a few thousand light years with our own eyes. It's a very small area. We can't see any. We can only see the notion of where the galaxy is, the Milky Way, and that's. Ouch.
Well, ARP's work actually shows that it's like 3 petals, and each one of those quasars is going right down the axis that we are in the center of. They're not spread out on the edge way far away from us, as the redshift would tell us it is. But ARP is right, and that empty cone that's in those other pictures, that's one of the leaves as well. So all the quasars are going down the center, or most of them are in the center of those going down. Both of them, all 3 of them are going down axes. This is exactly what the bubbles that we are, that my lady says that there was 3 of them. And that's exactly what ARP has for his. So thank you.
Well, no, it's interesting trying to ascertain. Like, I'm obviously not an expert on this. This is why other people are here. But I begin to see that what you end up looking at in like how a quasar could be ejected from this galaxy. Yeah, I can see that. There's been some talk that some things are that we consider to be that each galaxy itself has little galaxies around them in a halo. Stuff like that, like
Magellanic clouds, for instance.
Yeah, and how close are these? Would they be considered quasars if they were further away?
Quite close.
Well, that's what
there are things in the galaxy that are farther than some of the Magellanic Cloud portions.
Yes, and this is what I mean, and we're seeing them because they're so close up. But we do see them orbiting other galaxies, and we see them forming in predictable places that you would see where the pinches of the magnetic fields begin to just like the hourglass shape of nebula, for example.
And where the jets emanate from where the relativistic jets emanate from the poloidal fields.
It's just crazy the way that you start seeing how everything is a giant web.
we'll talk about the small and the big. You were just talking about an asteroid that had 5 satellites around it. So this is a basic principle, I suppose.
I just love that idea of the asteroid with 5 freaking satellites around it, all going. I'm not going to smash into that satellite like a little ionized atom out there floating around like a
And
weird
it's probably
fractal
conscious.
of an ionized
Yeah, it's probably
atom.
conscious too.
It's a good analogy, actually.
It's fantastic.
It's amazing. And we're starting to see this more and more in the way things are linked together. It's and
You can see the dynamics in a lava lamp. It's really easy to see the dynamics of it in a lava lamp.
I have a correction. Ultima Thule is not a comet or a asteroid. It's a planetoid, just like Pluto, because it's fairly large. I mean, it's not small like a comet or an asteroid. It's massive.
It's got
You
more
take
comets
it
than
back.
the Earth had around it in 1952. I mean, more satellites than the Earth had around it in 1952.
Well, yeah,
That's true.
but
We just had what? We had
That's just great.
2 satellites and 1 dead dog.
What's that?
I said we had 2 satellites and 1 dead dog.
Oh yeah, something like that. Something like that. Yeah.
Russians set up
Well, when they finally come up with a definition of mass, maybe they'll be able to have a definition of what's a planetoid or a planet.
Yeah. Those should be
well, we
related,
see
right?
the problem with asteroids that they have comet-like characteristics. So, what's a asteroid? What's a comet? You know, and obviously the orbit is going towards an anode, being the sun. Totally makes a lot more sense than their sublimating snow and ice ideas. Which
Did any of you guys see the guys and or gals see the video that we did on one of our cosmology segments about a neutron star that's moving at roughly the speed of the solar wind? I think it's something in the realm of 200,000+ miles per hour. Yeah, Neil, what, you don't watch our videos? What is up with you, man? Jeez, you recommend our channel and then you don't know what's in the content. You son of a.
my mother is a saint.
It was back in the early and mid 90s, I believe. One of the thumbnails actually, it shows the dates that this thing was observed, and it was traveling at a scale consistent with the solar wind. So somebody was looking at an object and they said, "What the hell is this?" It caused occultation of the object they were looking at, and they were like, "What the hell?" And they were using a very sophisticated, probably a radio telescope, and they're like, "What was that?" And then they figured out what it was, and they were like, "Huh?" And then they measured it a month later, and then they measured it like 18 months later, and it's been known about since the mid 90s. It's basically a comet moving at the speed of the solar wind, which appears to have the mass of a neutron star. If that doesn't freak you out, I mean, if you're worried about Nibiru, worry about neutron stars traveling at 200,000 miles per hour.
Well, I don't think there's anything such a thing as neutron stars, but that doesn't change anything with regards to how fast it's going.
I was going to say,
Yeah,
neutron.
Whatever it is, whether it's a wave or a particle, it's about that speed. So cheers.
Even if it is just one single particle, that's bad enough right there.
Yeah, it's a crazy object for sure.
Well, I wish I could keep this going all night long, but unfortunately, I do have to go a bit early, so I can't stay. But I still think that I still have at least another 15 minutes before I have to get going. So,
well, don't forget at the end of the. Sorry, Daniel. I was just going to promote you.
Well, that's what I was going to say. We do know he's coming in.
That's right. That's too many protons happen there. No, go.
No, I was just going to say, don't forget, Neil, to if you could provide the link at the end of the show to for Spatial Masses math, whatever. I butcher names. His show that's coming up at 4:00. Everybody that's here that has the time can go watch it.
Yeah, that's about 12 minutes.
Check it out. Eugene and I talking about some pretty serious stuff, but not getting too insane into it, and some appropriate visuals to go along with the conversation. I think you may enjoy. So check it out.
What time is that, Eastern Standard or whatever?
It's in like 14 minutes. 12 minutes, something like that.
Yes.
4:00 Eastern Standard, which would be 9 p.m. Universal Time.
Which is pretty awesome. And I'm glad that you got a chance to go over this, because it's really important that we understand that now that once we can understand what the nature of reality is, we can begin to understand that some of these grand unified theories were based on incorrect assumptions. If we go with the correct assumptions, as we were talking before, there's no difference between expressing a bullet in force in newtons. I can express that force in newtons, Newton meters, I guess, because, anyway, I can express that whole thing and then put that whole thing into joules. Like if I could catch the entire bullet with an arm, and it wouldn't go through the hand of the thing, how much energy could I catch out of that bullet? And I convert it into electricity. Like, that's the kind of thing that I think about when it comes to that. And we're on that level. We can do that. And if we don't have to deal with relativity, then we can certainly take that much knowledge and stretch it into, I guess you could say, quantum theory, which should be an extrapolation of these forces we already know into this, if we're on the right path. And unfortunately, I think only like one person in the entire world is working on that in our favor, which is like Stephen Carruthers. That's it right there. So all hail to him.
And just keep in mind, Eugene is a guy that understands electric universe paradigm. He has to understand all of the standard models of physics and so on. He's currently in a PhD program. So,
yes, I would never. If Eugene and I argue, it is always about something good. Like, I mean, the nitty gritties of something, because the general truth of it, I have nothing except for great respect for his brain. I'll tell you that. So.
Yeah, and I'm sure that he has the same thing going there that Monty from Sapphire has. That he, to quote Monty said basically, he doesn't care if the universe is electric or not. He wants to know how it works.
Right.
So I think that's that's kind of at the heart of what everybody's saying, whether it's Robitaille or whoever. There's some kind of there's a lot of progress to be made for sure. Let's hope Eugene's pessimism about the solar orbiter that should be launching tonight from the ESA out of Florida is better than the Ulysses, because it's going to fly at a much lower declination. So he's a little pessimistic about it because it's not going to be kind of right above the solar poles, but still super exciting to see that mission going off at the same time the solar probe's going.
I'm looking forward to that too.
So there's great data, all kinds of interesting stuff happening.
If we could finally, I thought this was really neat. This article, you guys can see it on the page in the future or something, whenever it comes up. But it's about, it's from NASA about plasma from 2009, and actually from 1999, sorry. And it says, As photographed from space, the Earth looked like it's floating in black void, but unseen by our eyes and most cameras, the Earth is actually surrounded by a complex system of interacting electric and magnetic fields, electric currents, and charged particles called the magnetosphere. And it was like, well, thank you for actually saying that. You know, where you could say it, because now they try to sort of like hide it, which is so odd because... and they're saying the solar wind, these particles constitute a plasma, a mixture of electrons, negatively charged, and ions, atoms that have lost electrons, resulting in a positive electric charge. And
yeah, I think it's weird that it happened so long ago, but it still isn't at all understood mainstream. Most people, if you tell them that, they'll go, "What's going on in space?"
Exactly.
And it's a testament to how long it takes for stuff to sink in. It's nobody's fault. You know what I mean? People are busy doing all kinds of various things. It takes a long time. The densest brains probably take the longest time for stuff to sink in. They're like,
well, and let's be fair. Let's be fair. The only reason that this is actually something that I mean, it makes sense in a way that people who are electrical engineers are jumping over this because they're saying, like in my mind, I'm screaming it. Like I want to be screaming it all the time because I'm like, this is how we think all the time. As electrical engineers, you don't actually see electricity ever. You can feel a magnetic field.
Well, you think about loads. You spend a lot of time thinking about loads. That's
exactly.
That's
exactly. You know what I'm talking about. It's all about the loads,
electrical.
Benjamin.
I mean, the ones from induced by circuits. Yes,
but
not.
I know.
Yeah.
Right. So anyway, but the issue is though, I mean, in a way, you have to mentally imagine these little things going through wires that you can't see. I mean, nothing moves on a circuit board, but magic happens, if you know what I mean. Once you're doing it, right? Once you've constructed the electrons to do things and to count numbers for you and to store things into memory and to change switches and to adjust fans, and you're like, oh, I have the power, you know. But all of this is just happening inside like electric currents, like fluctuating and op amps moving, and that's it. Nothing's actually occurring going somewhere unless you're moving a motor or something. So when I see that, seeing them talk about it around the Earth and saying, well, you can't see them, and that's different. Why? Like, nothing's changed for me. I can't see it anyway. I have to envision it all in my head. Now all you've done is remove wires. Now I have to envision where the currents are going without wires there. So I have to, put that together.
Can I paraphrase in a super provocative way? You can't see the loads until they come to the surface, much like magma and lava.
Penis.
And that's completely from an electrical engineering perspective, not from any extreme homosexual undertones.
Hey, I'm all for this extreme homosexual undertones. I have zero problem with extreme homosexual undertones.
I think it's fine.
And here,
I
sir,
fear for the rest of you. I concern myself with the fragility of the rest of you. I think it's hot.
And here is Topper Bottoms.
Yeah, let's just get dive right in.
Stern but sensual skipper of the USS Rough.
And just every male out there right now, get in touch with your female side. It's okay. It's all right. Not scary. Don't worry. It's not going to hurt you.
It's all natural.
Nothing will happen.
It's 100% natural.
Oh, God.
By the way, I have a girlfriend, so Daniel Tosh, if you think we should do something weird off behind the scenes, don't call me.
Well,
yeah, no.
Are you
straight
sure?
Loads, straight loads.
Halloween, I'm willing to dress up.
Loads.
I'm willing to dress up.
All the loads are straight.
But homo okay, but no homo new.
Not
okay.
Maybe not in drag or anything.
I'm fascinated with
loads.
Male ejaculation, but it's not a gay thing. Not.
We're talking about electrical circuits. This is out of hand. Oh my goodness.
Yeah, we have some obviously anything interesting to divert our attention for the next 3 or 4 minutes.
Good God, chat. There's no talk of loads in the video about the theory of everything with Eugene coming up on the YouTube channel.
Here's something just so everyone at home can know. February.
This is the director's cut. We're moving into the director's cut now.
Eugene will confirm we did not talk about loads.
A dairy farmer in a small town near Great Salt Lake, Utah, made an incredible discovery on his property. Basically, he found a 12-meter-long humpback whale lying in the middle of a field, hundreds of kilometers away from the ocean.
It was dragged in by wild hyenas.
Yeah, I'm sure. There's no tracks. There was no. They thought it was a prank or something, but no one could figure out how they would actually move it, and it looks like it fell there.
Tornadic winds. Yeah.
Isn't that crazy? A whale landed in the middle of Utah.
Well, what would be weird is just thinking about, like, if the whale was encompassed in water and if it was breathing while it was swimming through the air. Like breathing. Oh, wait, they breathe air.
Yes, yes, they do. Yeah.
Well, it's just weird.
Yes, they do.
I think I need to remind you all that pigs have spinal penises. I just think it's important that we note that at this point.
Was the missing cow found underneath the whale? What?
No, but that scene that you're discussing there is actually from the movie Hitchhiker's Guide to the Galaxy with the whale falling from the sky. If you haven't seen it before.
I forgot about that.
Let's see if I can...
I particularly like the shovel to the face episode.
No, I'm actually talking about the movie where they show the whale falling.
Yeah, I remember. But I remember them going down to the planet, one planet, and they take a step and they get a shovel-like thing in their face.
They do get a shovel in the face?
Something from the ground popped up and smashed them in the face every step they took. So yeah, it was funny.
Yeah, that's a whale.
Well, we're going to go out on it. I think the unconscious programming that we have. I would always go out on that we need to do affirmations, even to ourselves, that the paradigm, or not the paradigm, the philosophy of materialism, saying that everything is dead, everything is unconscious, everything is not charged, everything is disconnected, that even us, and we have to teach everybody else, that yes, in fact, we are alive, that we are conscious, that we are charged and connected to the entire cosmos. And if we don't say those affirmations to ourselves and to others, we're going to be still holding on to these unconscious things ourselves.